Welcome back to my channel. Greetings to you wherever you're watching this from. This evening basically I'm just going to try and solve the midterm question for our Electronics 2 class. This covers all that we did in chapter 1 of our Electronics 2 course. So briefly and quickly go through these questions and try and solve them. So the first question was, what is a tuned amplifier? What is a tuned amplifier? So with that, if you are able to answer that correctly, you would be earning yourself a mark of 2 marks. And the answer that was expected was that you would define briefly what a tuned amplifier is. And it is basically a tuned amplifier is an amplifier which has or involves a resonant circuit, okay? And its intended purpose is basically to do selective amplification within a narrow band of frequencies. You would realize I'm not trying to give a verbatim definition. So basically what was expected as a definition for tuned amplifiers is basically an amplifier that has a tank circuit or a resonance circuit, which is basically intended for selective amplification within a narrow band of frequencies. So that would have been the answer for A. Okay, so it is an amplifier involving a resonant circuit which is intended for selective amplification within a narrow band of frequencies. So that is the basic definition for a tuned amplifier. Then the next question is, what is the fundamental difference between wideband amplifiers and tuned amplifiers? The fundamental difference between wideband amplifiers and tuned amplifiers. For that, the fundamental difference is that for a wideband amplifier, you would realize that the gain remains constant over a wide range of frequencies, but it only falls at the low and then high frequencies. And then for the tuned amplifier, the gain is only maximum at the center frequency or the resonance frequency. Okay, so the fundamental difference between wideband amplifiers and tuned amplifiers basically is that the gain for wideband amplifiers remains constant over a wide range of frequencies. But falls at low and what high frequencies. Okay, so to further explain this, let's explain it using the diagram. Okay, so assuming this is this is angular frequency, this is gain, this is gain in dB. So let's say this is our tuned amplifier frequency response. Pardon my sketching. So this is tuned amplifier. And then we have, for the wideband amplifier, the frequency response. So this is also gain in dB. And then for this, what you would normally have is that you have something like this. Okay, so for the tuned amplifier, you realize that the center frequency is usually somewhere here. Okay, that is where you have the center frequency or the resonance frequency. Okay, just a second. Okay, now you realize that for the tuned amplifier, the maximum gain is at the apex of the frequency response. Okay, and you can find the maximum gain or the highest gain at that point. However, when you take the wideband amplifier, okay, the wideband amplifier, you realize that the gain remains constant over a wide range of frequencies. Okay, so the gain remains constant at this point, but it falls off at the lower and then the higher frequencies. Okay, do you understand? So that is a fundamental difference between the tuned amplifier and then the wideband amplifier. Now, there is another question which asks for the advantage of a tuned amplifier over a narrowband amplifier. Okay, so the advantage is very simple. A tuned amplifier's advantage over a narrowband amplifier is basically because the tuned amplifier can select different frequencies. Okay, so tuned amplifier can select different frequencies as needed. Okay, so that is the answer for that. And then the next question was to state two applications of tuned amplifiers. Okay, so tuned amplifiers are used in A, televisions or TV, and then in B, radios. Basically, in television and radios, they are used to select desired channels where you have a lot of channels to pick from or to choose from. And then to add one, we will say instrumentation systems. Okay, and then for instrumentation systems, what tuned amplifiers would basically be used for in instrumentation systems would be to isolate signals. Okay, so in an instance where you have several signals going through a system, and then those signals need to be differentiated. Tuned amplifiers can be used to isolate these signals because they are of different frequencies. Okay, all right. Now this then leads us to the main calculation question, and then in that question there was the question that a single tuned amplifier with capacitive coupling consisted of a tuned circuit having resistor R1 or resistor R, which is 10 ohms, and then an inductor which is 20 millihenry, and then a capacitor of 0.05 farad. This should have been microfarad, but don't worry, the principle still holds for the steps we would use for the calculation. Let's just go ahead and use that for the calculation. So that is the B part of the question. And then for the B part of the question, normally when you're answering questions as a student for exams purposes, it is always better to kind of write your answers in a way that looks very presentable to whoever is going to be assessing you or is going to be marking your script. So first of all, what we need to look out for is the data we can get from the question. So from that, the first thing we look out for, we'll see we have resistance R, which is 10 ohms. Always remember to add your symbol. And then we have, and then we have so we have our resistor R equals to 10 ohms, and then we have our inductor, which is 20 millihenry. So 20 millihenry is the same as 20 times 10 raised to the power minus 3 Henry. Okay, so and then we have our capacitor to be equals to 0.05 farad. Now, the first part of the question asks that we calculate the resonant frequency. Okay, so we'll go ahead and do that quickly. Now, you remember that the formula for calculating resonance frequency, as we derived in our previous lectures, would be equals to 1 divided by 2 pi and then the square root of LC, which is capacitor times inductance. Capacitor times, capacitance times inductance. So we'll have 1 over, from the data we have, 2 pi. We already know pi is a constant. If you're using your calculator, you can just select pi and then you move on. And then, so for LC, we'll have 20 times 10 raised to the power minus 3 times 0.05 farad. Okay, so if we do that and you take your calculator and you solve this, you're going to get 1 over, so 2 shift pi times the square root of 20 exponent minus 3 times 0.05, and that is giving us 0.1987. So if we are to find this, this will give us 1 divided by 0.1987, which is giving us 5.03 hertz. Remember, the question asks that you leave your answers in 2 decimal places. Okay, now the second part of the question asks that we calculate for the Q factor. So to calculate for Q factor, so for Q factor, we also know the formula for Q factor to be Q equals to XL, that is inductive reactance, divided by resistance. And then inductive reactance is the same as 2 pi FRL divided by R. So our Q factor formula becomes this. Okay, so same from our data. If we're going to input our data, we're going to have 2 pi. We know our resonance frequency to be 5.03 times our L, which is 20 times 10 raised to the power minus 3, all divided by 10. So this gives us, with your calculator, 2 pi 5.03 times 20 exponent minus 3. Okay, let's take it again. So 2 shift pi times 5.03 times 20 exponent minus 3, all divided by, okay, so 2 pi times 5.03 times 20 exponent minus 3 divided by 10. Sorry. By 10. That is giving us 0.063, but we said to leave our answers in 2 decimal places, so this will be the same as 0.06. Okay, that is our quality factor. Then the next question asks that we calculate the bandwidth. So to calculate bandwidth, the formula we know for bandwidth is Q equals to FR divided by bandwidth. So bandwidth will be the same as FR divided by what? Q, which in this case would be FR is 5.03 divided by our Q factor, which is 0.06, and that would give us 5.03 divided by 0.06, and that will give us 83.83 hertz as our bandwidth. Okay, so that is the calculation. So this is what is expected of you for the midterm. All right. Thank you for watching this. If this tutorial interested you and you would like to see more of these, what I would suggest you do is that you subscribe to the channel Linutech, and then you also ring the bell, or you click on the bell, so that anytime there is the upload of a new video, you would simply be notified, so you can have access to it and watch same. So thank you for your time, and do have a nice time. Bye.